Okay, this is a presentation of our Module 4 review. These are the concepts and standards that we will be responsible for going into our Module 4 assessment. So let's go through this carefully together, and you guys please let me know if you have questions on any concept. So on this first slide right here, these first three problems, they give you either an inequality or interval notation or a graph, all right, for a set of numbers. And they give you one, and you're going to have to come up with the other two. Now, most people like a visual, so I like to always start with a graph. So if they did not give me a graph, I'm going to begin this problem, number one right here, by doing the double inequality. -4 is less than x, and x is less than or equal to 2. I'm going to graph that. So I look at my endpoints. My left endpoint is -4, and I look then at the inequality. -4 is less than x. There's no equals there. So I go to -4 on my number line, and because there is not an equals, I need to put an open dot on my left bound of -4. And then x is less than or equal to +2. So at +2, because of the equal sign right there, I need a solid dot. And these x's are everything in between these two endpoints, including the endpoint on the right too. And that's what this line graph means right here. -4 is less than x, and x is less than or equal to the 2. Now, let's go to the interval notation. And as soon as I say the word interval notation, I picture the comma, like that. And then I like to put my bounds in first. So my left bound is a -4, and my right bound is a +2. And then I think, do I need parenthesis or bracket on my bounds? So this is open. Note again, there's no equal sign right here, so I need a parenthesis for my left bound, meaning x cannot equal that -4, and a bracket for my right bound because x can equal 2. And there's number one. Number two, all right, they gave us the interval notation, all right? So look at the left bound of -4. But there's a parenthesis right there. So at the -4 on my number line, I'm going to put an open dot. X cannot equal -4. And then I'm going forever towards infinity on the right. And because I can never reach infinity, that's why there's a parenthesis here. So that means this graph only has the bound on the left. And then we do a ray going to the right forever. And there's your graph right there. Now, because we don't have two endpoints right here, this is just a single inequality. And again, look at this graph. These are all my x's right here, and these x's are what? Greater than that -4 right there. So x's, and again, greater than because my arrow goes to the right, and there's no equals because it's an open dot right there. So just greater than, and that bound one more time is a -4. And then finally, number three, they gave us the graph first. I like that. So I'm going to go to the interval notation probably first. Let's see if I did comma. Oh, nope, I'm going to the inequality. Okay, well, simple as that. So let's think about the inequality now. Okay, so again, there's only one bound to the right this time. So these are all my x's right here. So I'm going to start with x, all right? And notice solid dot at 2, and my arrow is going to the left. That means x is less than or equal to this 2. So let's go less than or equal to, and my bound on the right is the 2. Now let's go to the interval notation, which is going to look very similar to this one right here, except comma. Now look at the graph right here. We're going forever to the left. So my left bound is -infinity, which really isn't a bound because we can't reach it. And my right bound is the 2. Okay, now you think parenthesis or bracket. On the left, since I can never reach -infinity, I have to go parenthesis. And on the right, well, that's closed right there. There's also an equals right there. So I'm going to put a bracket on the 2. And that's called a half open interval where x can't equal 2. And there's our first slide right there. Okay, in 4 through 11, solve for y. All right, so we're solving inequalities. And look at this. This is multiple choice. Very cool. Okay, now you guys, when I do a multiple choice test, when I do any multiple choice problem, all right, I do the problem just like free response, and then I get my answer, and then I go look for my answer. I never look at the answers first because I don't want them to sway me in any way. I just look at negative 5y is greater than negative 40, and I'm thinking, okay, this is a one-step inequality. How do I undo multiplication by negative 5 right there? Well, we're going to divide both sides by negative 5 because we're solving for that y right there. Now, here's your big rule. When you multiply or divide both sides of an inequality by a negative number, you've got to reverse the inequality symbol. So this greater than comes down here as a less than. And then on the left, these negative 5s would cancel, leaving the factor of y. So y is less than, and now a negative over a negative is positive, and 5 goes into 40 8 times. And if you're not sure on your arithmetic, double check on a calculator. All right, so y is less than 8. There's my answer right there. Now let's go over here and we'll look at b. Y is less than 8. Now, I love doing multiple choice math problems like that because, you know, when I do this, I'm very confident, but then when I see my answer over there, it's like, oh, I know, I got it. All right, number 5. Ooh, there's a few more steps on number 5 here, all right? And they didn't give us a lot of room here to show our work, so let's do our best. Now, notice first thing, in this inequality, you have 6 y's on the left and you have 4 y's on the right. Let's get our y's on the same side. And I'm going to subtract the 4 y's from both sides, like that. And that way, my number of y's stays positive, which makes the problem a little easier. You could have gone either way there, though. And when you add or subtract, that does not affect your inequality symbol. So we're still greater than or equal to. And then I go 6y minus 4y. Those are like terms, so those would be 2 y's. And then plus 10 is greater than or equal to. And on the right, we have 4y minus 4y cancels, leaving negative 40 right there. All right, now it's a two-step inequality. You have to undo this addition of 10 first. All right, so let's subtract 10 from both sides. Now I'm out of room, so I think, what would I put down here? And I'm gonna have to write this over here somewhere. Well, adding or subtracting does not affect my inequality symbol, so it's still going to be a greater than or equal to. All right, and on the left, I have 2y plus 10 minus 10. Well, that leaves me just the 2 y's. 2y is greater than or equal to negative 40 minus 10 more. That would be negative 50. And now you divide both sides by 2. And we divided both sides by a positive number. So again, our inequality is not affected. Yeah, put that over there. And on the left, my factors of 2 cancel, leaving my factor of y. Y is greater than. And a negative over a positive is negative. So that's going to be a negative. And 2 goes into 50 25 times. So y is greater than or equal to negative 25. Let's hope we see that answer. No, no. Y is greater than or equal to, hey, there it is, see? Hey, this is going great. All right, number 6. Well, my first step would be, all right, I'm solving for the y, so I've got to get rid of that 1 right there. So can we just subtract 1 from both sides? And equals, this is just an equation, isn't it? So look at the left now. 1 minus 1 cancels, and you're left with 2y over 3. I'm going to write that as 2/3 y. All right. And then on the right, I have 5 minus 1 is a 4. And now, how do you undo multiplication by a fraction? Remember this rule. It will serve you very well. You multiply by the reciprocal of the fraction, both sides. So what's the reciprocal of 2 over 3? It is 3 over 2. Just like that. I love this because I get to cancel all kinds of stuff now. Do you see my factors of 2 cancel? And my factors of 3 cancel, leaving my factor of y. Y equals, and over here on the right, 4 times 3 halves. Well, does 2 go into 4? It does. How many times? 2. So 4 times 3 halves is nothing more when you cancel right there than 2 times 3. So y equals 6. And I look at A right there, y equals 6. So you guys, again, on the test itself, multiple choice, all right, they will probably be worth 4 points each, all right? And if you show your work but miss the problem, but I can see where you made your mistake by looking at your work, I can give you half credit on those. So make sure on the multiple choice, all right, you show your work, all right? And if you do your steps carefully, you're almost guaranteed to get the correct answer in all 4 points for every problem, all right? But if you've shown your work and you made an arithmetic mistake somewhere, I can give you half credit, all right? Don't just look at the problem and go, oh, this looks right, I'm going to circle it. Because if you miss it and you didn't show any work, you'd lose all your points on that problem, and you can't afford to do that. Thanks, guys. All right. Another slide of these. Awesome. All right. Well, number 7 looks like number 6. Oh, yeah, but this was an equation, and number 7 is an inequality. 1 plus 2y over 3 is less than 5. So now we're going to do the same thing here. We're going to get rid of that 1 first, so let's subtract 1 from both sides. And that will not affect my inequality symbol at all, so the less than is still a less than. And on the right, the 1 minus 1 is gone, and I'm left with 2y over 3, which again, I'm going to write that as 2/3 of y, is less than 5 minus 1, that'd be a 4. And now same thing, to undo this multiplication by 2/3, we're going to multiply both sides by the reciprocal of 2/3, that would be 3 halves. All right, good. And now we multiply by positive there, so my inequality does not change, and start canceling away again. There goes the 2's, there goes the 3's, so y is less than, and same thing over here, 2 goes into 4 2 times, so that becomes a 2 times 3 is 6. So y is less than 6, and that's D. All right, number 8. Well, we better get rid of this 3, so how about we subtract 3 first? Okay, that will not affect my inequality. So 3 minus 3 is gone, and I have negative 6y is less than or equal to negative 30 minus 3 more. That's a negative 33. And now we have to undo multiplication by negative 6, so let's divide both sides by negative 6. And when we divide both sides of an inequality by a negative number, we have to reverse the inequality. So this less than or equal to, I'm going to write over here for room as a greater than or equal to. And on the left, my factors of negative 6 cancel, leaving my y. Y is greater than or equal to. Now, a negative over a negative is positive, so all we're going to have to do here for full credit is reduce the fraction 33 over 6. So you think to yourself, what number goes into 33 and 6? And isn't that 3? How many times does 3 go into 33? 11 times. How many times does 3 go into the 6? 2 times. So that becomes y is greater than or equal to 11 over 2. And you guys, if you're struggling with the arithmetic at all, you could put this into your calculator exactly the way you see it. Negative 33 divided by negative 6. And your calculator would probably give you a decimal answer of 5.5, which is okay. You could say y is greater than or equal to 5.5. Or if you want the fraction, your calculator will also convert a decimal to a fraction for you. All right? So let me know if you haven't done that kind of stuff on a calculator before, and meet with me and I'll show you. Anyway, y is greater than or equal to 11 over 2. That would be B. I think we're getting 100% here. All right. Oh, now we have a literal equation right here. We're still solving for y. So the first thing we have to do is get rid of those 3 x's. So above, we subtracted 3. Here, we're going to subtract the 3 x's to isolate that y right there. All right, so equals. And now I have 3x minus 3x is gone, so I have negative 6y equals, now these are not like terms, I cannot combine them. So I could write this negative 30 minus 3x, or minus 3x, negative 3x minus 30. It doesn't matter what order. So I did negative 3x minus 30. All right. Now we have to divide both sides by negative 6. And what I did is I just divided every term by negative 6. All right. So let's take a look here. Well, on the left, the factors of negative 6 cancel, leaving the y. And on the right, look at this. Now I have a negative over a negative. That's positive. And 3 over 6 would be 1 over 2. So that I'm going to write that as an x over 2. You could have also written that as 1/2 x if you wanted. And then here, negative 30 divided by negative 6. That's also a negative over a negative, which is positive. And then 6 goes into 30 how many times? 6 goes into 30 5 times. And again, if you're struggling at all, double check on your calculator. Just go negative 30 divided by negative 6. Guess what? Your calculator would tell you plus 5. So I'm looking for y equals x over 2 plus 5. And there you have it right there. Now, what if I had divided the whole side by negative 6 instead of term by term? I'd have the same answer in another form. So if you solve an equation like this, and you know you're right, but you don't see your answer, well, maybe your answer is down here on a multiple choice written in a different form, so you can always double check that too. All right. Okay, let's do 10 and 11. This looks like our last two solving problems. All right, so on number 10, well, let's see. We have two options here. We could either distribute the 10 to both terms in the parentheses on the left, but I'm looking and see the 160 on the right. 10 goes into 160 evenly. So I think I would divide both sides by 10. Yep. All right. And we divided by a positive, so that does not affect the inequality. Greater than or equal to. And now on the left, the factors of 10 cancel, leaving the quantity 6 minus 2y. I don't need the parentheses anymore. And on the right, we have 160 divided by 10. That would be 16. All right. Well, now we have to get rid of that 6. So that's a positive 6 right there. So let's subtract 6 from both sides. And adding or subtracting will not affect our inequality. So it's still going to be greater than or equal to. And on the left, we have 6 minus 6 cancels, leaving the negative 2y. And on the right, we have 16 minus 6, which would be a positive 10. And now we need to divide both sides by negative 2 to undo this multiplication by negative 2. Okay. Now, careful here. We multiplied both sides by a negative number, so we have to reverse the orientation of that inequality. Greater than or equal to becomes less than or equal to. And the negative 2's cancel. So y is less than or equal to. What's a positive over a negative? That would be negative. And 2 goes into 10 5 times. Negative 5. Y is less than or equal to negative 5. And there it is. Hey, look at us. Okay. Now, the same situation, but this is literal now. This is a literal equation. We're still solving for that y. So let's do the same thing. Let's divide both sides by 10. 10's cancel on the left, leaving 6x minus 2y this time. And on the right, we have 160 divided by 10 would be a 16. And now let's subtract 6x's from both sides. All right, and 6x minus 6x is gone, leaving the negative 2y's. And over here on the right, I cannot combine those, so I could write this 16 minus 6x or negative 6x plus 16. Whatever you want to do there on your order. All right, and now, like before, we've got to undo this multiplication by negative 2, so let's divide every term by negative 2. All right, so let's see what we have here. Well, on the left, the factors of negative 2 cancel, and I have a y equals. Now here I have a negative over a negative is positive, and 2 goes into 6 3 times, so that would just be 3x's. And then I have a positive over a negative is a negative or a minus. And 2 goes into 16 8 times. So what do we got right there? We got 3x minus 8. Y equals 3x minus 8. There it is, C. Okay. Number 12. Graph y is less than 8 on the given number line. Oh, that's easy. So on the number line, first I need to make one of these hash marks an 8. Doesn't matter which one. So how about that one right there? 8. Now, less than. There's no equals, so the dot on my 8 would have to be an open dot. And y is less than that 8. Wouldn't that be everything to the left of that 8? And there's my graph of y is less than 8. Now part B, solve and graph the solution to 19 is greater than or equal to 1 minus 2x on the given number line. All right, so we'll solve it and then graph it. So first we need to get rid of that positive 1 right there. So let's subtract 1 from both sides. Does not affect the inequality, greater than or equal to. And 19 minus 1 would be 18. And the 1 minus 1 cancels, leaving the negative 2x. And now we've got to divide both sides. See, the x is being multiplied by negative 2. We've got to undo that. Let's divide both sides by negative 2. And now we divided both sides by a negative number, so we have to reverse the inequality symbol. So this greater than or equal to becomes less than or equal to. And a positive over a negative is negative. And 2 goes into 18 9 times. On the right, the factors of negative 2 just cancel, leaving the x. So x is greater than or equal to negative 9. Notice how I read that from the variable too. So on one of these hash marks, I'm going to need a negative 9. Doesn't matter where. Oh, I put it way over here on the left. Now I look at the inequality. Do you see the equals? Solid dot. And now this is why I read from the variable x is greater than or equal to negative 9. That would be everything to the right. And there's part B. Okay, number 13. Katie is saving to take a trip to Hawaii that will cost at least $1,200. Let's translate this statement, at least $1,200. Well, I'm going to start with the easy stuff. I know I'm dealing with $1,200. How am I going to write at least $1,200? Well, wouldn't that mean I need greater than or equal to $1,200? So there you go, greater than or equal to $1,200. This is how a mathematician says at least $1,200. So let's see what she has so far. So far she has received $240. So let's put this over here on the left. And she adds $120 to her savings each week. So we're adding, what are we adding? $120 times the number of weeks she is saving. I would let x equal number of the weeks and go 120x. And there is my inequality. Now, how many more weeks must she save to be able to afford the trip? So now all we're going to do is solve that inequality. So if I'm going to solve for this x number of weeks right here, I'm going to get rid of that plus 240 by subtracting 240 from both sides. Does not affect my inequality. And 120x and the plus 240 minus 240 cancels. Greater than or equal to 1,200 minus 240. Would that be 960? There you go. And now let's divide both sides by the 120 to undo the multiplication by 120. There you go. Greater than or equal to. And on the left, the 120's cancel. And that leaves me my factor of x. So x is greater than or equal to. I think 120 goes into 968 times. But I'm going to double check that on my calculator. So 960 divided by 120 is 8. So x is greater than or equal to 8. 8 what? That's weeks. 8 weeks. And there we go. So we set up the inequality, we solved the inequality, and we answered the question. X is greater than or equal to 8 weeks. That's a great problem. All right, one more story problem. And I think this is it, you guys. So Hope has a savings account with a balance of $840. So let's start with that $840. And she is withdrawing $40 every month. So 840 we're withdrawing minus $40 per month. Can I write that? 40x. And that's Hope's account right there. That will be the balance where x is the number of months. Now, Faith has a savings account with a balance of 120. I have a feeling we're going to compare these two accounts, so I'm going to put 120 over here on the right. 120, and she's depositing $20 per month. Depositing money, so let's add to that. $20 per month. Can I write that 20x? Okay. For how many months will Faith's account balance be less than Hope's account balance? So let's make sure we know which one is which. So wasn't this expression on the left Hope's account balance? And the expression on the right is Faith's account balance? And now let's put in the appropriate inequality. For how many months will Faith's account balance be less than Hope's account balance? So I need to have the less than, and I'm reading from Faith right here. So Faith has to be less than Hope. Do you agree with that? Or you could have said Hope is greater than Faith right there. Okay, now let's solve for the x. So I'm going to get my x's on the same side. You see the negative 40x's? Could we add 40x to both sides? Does not affect our inequality. And now we have 840 is greater than 120 plus 60x's. Okay, now it's a two-step equation. Let's get rid of that 120. Let's subtract 120. Does not affect the inequality. And 840 minus 120 would be 720 is greater than, and that's 60x's. And now we're going to divide both sides by the 60. Okay, so that will not affect my inequality. And 720 divided by 60, is that 12, you guys? I think it is. You can double check on your calculator. Okay, oh, looks like I'm going to simplify over here first. And on the right-hand side, the 60s cancel, leaving x. So x is less than. And 720 divided by 60 would be 72 divided by 6, or 12. And 12 what? I left some room there. That is months, so 12 months. So x is less than 12 months. So Faith's account will be less than Hope's account for less than 12 months. All right. Boy, that was it. All right, now I hope you did these problems and then watched this video and checked everything. Check how you're showing all of your work. Remember now, you know, if you're showing your work, I can give partial credit. If I don't see work, I cannot give you partial credit. So get this done, all right? And again, the test will be the next time we meet, so make sure you've watched this carefully and you have all of your questions answered. You guys have a great day.